Since A and B are such small angles, it makes sense that angle C would be, you know, quite obtuse. So let's see if I can draw a picture here. Let's see. All right, definitely not to scale. A little bit embarrassed of it, to be honest with you. All right, let's see. Angle A we have, angle B. All right, let's talk about transitioning from degrees, minutes, seconds. These are ones that we could probably do pretty easily without a calculator, but formulaically, for example, to turn angle B here into just regular degrees, you take the degrees as is, that just carries over straight up, and then if there are any minutes, you would just divide that by 60, since there are 60 minutes in an hour. If there are any seconds, let's say there were some number of seconds, you would divide that by 3,600 and then just turn this into a decimal, and then you know what that is in just straight up degrees, okay? So we'd end up with 8 points, so 15 over 60 is a fourth, so 8.25 degrees. There we go. And then angle A would be 15, and then 40 over 60 is 2/3, so 50.6 repeating degrees. There we go. Okay. So it would be pretty easy to find angle C, since you have two of the angle measures. Angle C would equal 180 degrees, take away 8.25 degrees, and take away 15.6 repeating degrees. Okay. Now a notation check. Make sure when you look at your work, you do have the degree symbol each time. If I have to add it for you, I do charge you half a point every time I have to add it for you. So there you go. All right, so we end up with C being 156.0, whoops, that's not a 0.083, and the 3 repeats. There we go, degrees. All right, so we have that. Great. Okay, and I haven't had to use law of sines yet, but let's go ahead and see about using the law of sines. So we could have sine of, let's see, angle A is 15.6 degrees over A. And then I'm going to use the complete ratio. You know, there to figure this out. Okay, so let's look, angle A, or sorry, side length A would be 4.8 times sine of 15.6, oops, repeating degrees divided by sine of 8.25 degrees. All right, check your work. Make sure you have degrees symbol every time. Sorry, I'm taking a second to calculate it here. All right, so then it looks like we end up with approximately, actually I should write it a little cuter. Nah, forget it. 9.033. There we go. All right, and I'll just box that whole thing up there. Okay. All right, now in the past, I've had folks, once they know what A and B are, use the Pythagorean theorem to solve for side length C, and I ask you, would that make sense to use the Pythagorean theorem to solve for side length C? I hope you're saying no to that, since that is not a right triangle, so please don't fall into that trap. So how are we going to find side length C? Well, it looks like we'll end up needing to use probably law of sines again. So let's just do sine of, let's see, angle C was 156.083 repeating degrees over C. And then let's see, that would be approximately, or no, exactly. And then I always go back to the original complete ratio that we had. The idea is that we didn't, there was no chance we could have screwed anything up. Anyway, so cross multiply and divide. There we go, and then calculate it. We get approximately 13.561. There we go, it's a side length, so don't accidentally say degrees on it. And there you go, we have solved that triangle. All right, my friends, hopefully things are going okay. Let's look at example 2 here. Funny story for example 2. I have a friend named Ahmed whose dream job was to do, he's a wildlife biologist, and his dream job was to work in the redwood forest in Northern California. And he got his dream job and was always making, kind of telling me how much he hated math. And funny story, he came back from his first day of training at his dream job and was spitting mad because they talked about SOHCAHTOA and we're reviewing trigonometry. And anyway, it was just so funny. But anyway, so here's the idea. Part of his job was to figure out how tall redwood trees were. And as much as Ahmed would rather climb a tree than actually to do a little trigonometry, there were rules, safety rules. And so he had to use a clinometer and find angles of elevation and measure distances from the base of the tree to where he was standing when he took the measurement. And then Ahmed had to do trigonometry. So example 2 is dedicated to my dear friend Ahmed. So the note, though, from here on out, unless otherwise stated in the problem, we do get to assume the ground is flat and trees and buildings are upright. So Ahmed is standing 40 meters from the base of a tree that is leaning 8 degrees from vertical away from him. The angle of elevation from his feet to the top of the tree is 20 degrees and 50 minutes. And so for part A, I'd like for you to draw a picture that represents the problem. And for part B, find the length of the tree. All right, good luck.